Alright, back to working on the outboard today. Did some more research, found out a lot of people have had problems with the wiring harnesses being shot. Apparently when the insulation gets old on these, whatever they used fails. And general consensus is, even if you want to buy the aftermarket engine harness that's available for this, it's about $175. And the consensus is to just omit this plug altogether. So basically what they're saying to do is get rid of this plug, cut back to where you have good wire here on this harness, put a terminal block in here if you need to have the ability to remove the engine from the boat for storage, say, and make your own wiring harness. Also had a lot of people say that they couldn't get the tinned marine grade wire that apparently is used in a lot of these projects, and had other people say that they used regular wire, copper wire, without any problems. They used the heat shrink tubing and things like that to keep the water out of the connections. So next thing I needed was a wiring diagram, and within hours after posting a request in a forum, I was happy to receive this wiring diagram. Printed it out today, and much to my elation, the diagram shows that the actual part of the circuit here that has to do with the spark is really quite simple. You've got the blue wire that goes to the coil here, comes from the amplifier box, and then the amplifier box really only has three other wires. A black wire that goes to your points. So you can see there's the plug coming from the amplifier box. The black wire that goes to your points. And we've got the purple wire, which goes to 12 volts when the ignition key is on. And the gray wire is actually a tach wire for a tachometer. So there is actually a tachometer in this boat up in the front there. I have no idea if that works, but I'm sure the tachometer is just an option, not necessary to have a tachometer hooked up to it to make it work. So beauty is I can rig up a temporary wiring scheme that will allow me to energize this amplifier with 12 volts and pulse to ground the black wire, which would simulate my points, and then I should get spark out of this high tension lead. If I don't, then that would indicate that my problem is either a bad coil or a bad amplifier, either one of which is going to be bad news, because the amplifier box here is no longer available. So that would necessitate converting this back over to a conventional points condenser coil setup, which is done. People have said they've done it with a lot of success. But again, how much do I want to spend on this? I don't know. Okay, so I've got the ground hooked up, and I've got a 12 volt temporary lead going to the purple wire to the amplifier. I've got a pigtail that I've put on the black lead, which should normally go to the points, but in this case I'm going to just touch it to ground intermittently, and I should hear maybe a spark. Now I don't know what position my distributor is set at, so I don't know which one of these spark plug leads it would necessarily want to throw the spark out of. But what I can do is just listen closely and see if I hear anything. So let's see. This looks like a good enough ground. Alright. Not getting any action there. Let's see. Think about this for a second. Alright, I wasn't entirely sure I was getting a good ground. The other connection for the amplifier module here is that the bracket is grounded. So that's the ground. Again, purple's 12 volts, black is your pulse from the points, and gray is just attack. So let's see. Don't hear anything. Alright, so I was able to determine, now that I know that I have the wiring diagram, now I know that this is the points wire right here. So this single wire goes up to the breaker points, and then of course the points are grounded. So I should be able to check from here to ground and see if there's continuity of my points, and then I should be able to use that to figure out where to rotate this so that my distributor is lined up with the rotor. Well, check the continuity between here and ground. This is the ground return right here. It goes over to here for the points, for the breaker points, and this is reading open no matter where I rotate the crankshaft, so the points are not closing. They're probably pitted or rusted or corroded or whatever. Not surprised. But so I'm gonna have to pull the flywheel to get to those, and I don't have a harmonic balancer to pull this right now. Definitely the amplifier circuit here is drawing current because I get a little bit of a spark when I put this on, indicating to me it's drawing a little bit of current. I've disconnected the blue wire that comes out of the amplifier and goes to the coil here. I'm going to check the primary winding of the coil for continuity. Well, I got continuity, but when I put it on the ohm scale, it's really low. I mean, it's like almost a short. So right there, I may have a problem. I mean, if this primary coil is shorted, not only is the coil bad, but that would also mean it more than likely took out the amplifier. I mean, I'm getting 0.2 of an ohm for a reading here, and quite frankly, I'm getting 0.2 of an ohm for a reading. I'm almost getting 0.2 of an ohm just going to this grounding screw because I'm not getting the greatest connections here. So that almost seems like it's a short, unfortunately. Just for giggles, I put the volt lead on the output of that amplifier box just to see what comes out of that, and to see if it changes when I actually pulse that points connection. Doesn't seem to do anything. I don't know. I just got a feeling that I'm looking at a bad coil, bad amplifier, and bad points.